In this video, we're going to be talking about how to find the derivatives of inverse functions. So first, let's recap what an inverse function actually is. An inverse function is noted as f to the negative 1 of x. It basically undoes the action of the original function f of x. So that looks like an exponent of negative 1. That's really our symbolic notation for inverse. When you're undoing the original function, this really means that the x and y values are inverted, hence the name inverse function, or they're switched. The composition of inverse functions produces the identity function, which is just f of x equals x. So what that means is composition means when you're substituting or plugging one function into another. So if f and g are inverse functions, then f of g of x is equal to x, and g of f of x is equal to x. What we're going to be doing in this video is we're going to also be evaluating the derivative of an inverse function. Since inverse functions involve the composition of functions, we need to use the chain rule to take the derivative. For example, assume f and g are inverse functions and are differentiable. Then f of g of x is equal to x. When we take the derivative, think about how to take the derivative of this using the chain rule. It's the derivative of the outside, so f prime of g of x, times the derivative of the inside, g prime of x, and that would be equal to 1. We're basically going to use this idea to help us evaluate the derivatives of inverse functions. All right, let's take a look at some practice questions. First, let's start off with something relatively simple. We're going to find the inverse of y equals 2x minus 5, and then we're going to find the derivative of that. All right, when we find an inverse, we're going to switch x and y. So I have x equals 2y minus 5. And then we want to resolve for y. So I'm going to put the 5 on the other side. Divide everything by 2. And we could also write that as 1/2 x plus 5 over 2 is equal to y. So I'm going to put that over here just so I have some more space. That's our y. Now let's find y prime. The derivative of 1/2 x plus 5 over 2 is simply 1/2. Okay, now let's look at something that appears to be a little bit different, although it's a similar concept. So f of x is equal to x cubed. F of g of x is equal to x, and then we're going to find g prime of 8. So what this means is that f and g are inverse functions. Okay, we know that because when you compose two inverse functions, you get back the identity function, which is x. So this is the problem's way of telling us that f and g are inverses. All right, so we know that f of x equals x cubed. For the sake of this problem, I'm just going to put a y equals x cubed. And let's think about how we find our inverses, like in the previous problem. We switch x and y, and then we solve for y again. So to do that, I'm going to take the cube root of both sides. So y is equal to the cube root of x. And since this is really our inverse function, I'm going to now put g of x is equal to the cube root of x. All right, now I want to take the derivative of that. I'm going to move over here where I again have some space. Cube root of x is the same thing as x to the 1/3, so I'm going to take the derivative of that. I get 1/3 x to the negative 2/3. If I simplify that, that's 1 over the cube root, or 1 over 3 times the cube root of x squared. And we're looking to evaluate this at 8. When I simplify this, this is 1 over 3 times the cube root of 64. That's 1 over 3 times 4, or we get 1 over 12 as our answer here. So for questions 1 and 2, the problems had one similarity, which is that we were given one of the functions. You're going to see in questions 3 and 4, we are not given either of the functions. So we can no longer do this process of switching x and y, taking the derivative, and then sometimes evaluating like we did in number 2. We have to be a little bit more strategic about how we do this. So let's see, number 3 says let f and g be differentiable functions where f of g of x equals x. Again, that means they're inverses. If g of 2 is 7 and f prime of 7 equals -6, find g prime of 2. Okay. This might look like we have no idea where to start, but this is our key here because this is something that we can take the derivative of, as I showed earlier in the video. We're going to take the derivative of this using the chain rule. So derivative of the outside times the derivative of the inside, which is 1. Now we want to evaluate what's happening at 2, g of 2, times g prime of 2 equals 1. So g of 2 is 7. G prime of 2 is what we're looking for, equals 1. F prime of 7 is -6 times g prime of 2 equals 1. And if I solve for g prime of 2, I get -1/6 as my answer. So let's talk about this problem a little bit more before we move on. So I'm taking the fact that I know they're inverses and taking the derivative of that composition of functions. When I did that, I used the chain rule. Okay, so here's my work using the chain rule. And I took the derivative of the outside times the derivative of the inside. Now, we knew in this problem that we're looking to find the derivative at 2. So what I did is I replaced these x's with 2's. And then I substituted what I knew. Well, it's looking for g of 2 here, right? So if I highlight here just so you can follow, it's looking for g of 2. I know up here g of 2 is 7. Well, then it was looking for f prime of 7. I know over here that that's equal to -6. So I'm really just doing a lot of substitution here and simplifying until I get g prime of 2 by itself, which is -1/6. So sometimes based on the information that we are given, we are in fact able to evaluate the derivative of an inverse function without actually knowing what the function is. All right, let's try one more like that. So 4 says let f and g be differentiable functions where f is the inverse of g. If f of 1 is -5, f prime of 1 is 2, find g prime of -5. Okay, so notice one difference here is that we are not given that composition here, but since we know they are inverses, we know that f prime of g of x is equal to x. And we know the reverse, that g prime of f of x is equal to x. We know they're inverses. Okay, I'm going to work with this first idea, f prime of g of x is equal to x. Let's do what we did on number 3 and take the derivative of that using the chain rule. And we know we're looking for g prime of -5. So I'm going to change all of the x's to -5. And remember, we're isolating, we're looking for g prime of -5 here. So I don't know what that value is, but I see here that it's saying g of -5. And if I look at the facts that the problem gave me, I don't know what that is, right? I don't see anything here that says g of -5 equals. However, we do have this fact that f of 1 is equal to -5. Remember we talked about before that when you have inverse functions, the x's and y's are switched. That means g of -5 must be equal to 1. Now let's try that fact. So f prime of 1 times g prime of -5 equals 1. F prime of 1, we do know that that's 2. This is what we're looking for. And if I solve here, I'm going to get g prime of -5 is equal to 1/2.